Hello students, how are you? Hope you are fine. I am Rafiq Ahmad, Assistant Professor, Government College, Nawab Shah. My dear students, first you subscribe and share and like the College Education Department YouTube channel. Today, the topic of my lecture is Law of Radioactive Decay. Before defining this law, I would like to define some main points regarding to law of radioactive decay. So point number one, the radioactivity. As we know, the spontaneous emission of alpha, beta and gamma radiations from the nucleus of the radioactive elements is known as radioactivity. Those elements whose atomic number is more than 83, they are called radioactive elements. For example, uranium 92, radium 88, radon 86, thorium, etc. In the radioactivity, the disintegration is not uniform. So, it is considered as the random process. Sometimes the radiations from the nucleus are going out in the huge amount, and sometimes the radiations from the radioactive elements are going out in the low amount. What is the law of radioactive decay? Actually, it is the mathematical model of radioactivity. So, now we define the law of radioactive decay. The law of radioactive decay can be defined as the rate of change of disintegration dN is directly proportional to the number of atoms present. Suppose I have a glass of water and the water present in the glass is indicated by N naught. N naught is the original number of atoms present in the nucleus. Suppose I take water like that. Now the water which is eliminated from the nucleus is Dn. This water is disintegrated. These atoms are disintegrated from the nucleus indicated by dN in time dt. So the rate of change of dN over dt is directly proportional to n. Now n is the remaining number of atoms present in the nucleus after disintegration. Number of atoms has been decreased, so we introduce a negative sign here. This negative sign shows the number of atoms present in the radioactive element. Initially it was N naught, but after disintegration the number of elements is equal to N, and negative sign shows the N has been reduced because of the disintegration of Dn. So dN over dt is directly proportional to minus n. Now dN over dt is equal to, when we eliminate a sign of the proportionality, we introduce a sign of equality and constant. To minus n. Now dN over dt is equal to lambda into minus n, where the lambda is known as a decay constant. Lambda is called decay constant. It is different for different radioactive elements. Now, dn upon dt is equal to minus lambda n. I can write by applying the law of cross multiplication, dn over n is equal to minus lambda into dt. Now I apply the integration. Integration to both sides. Integrate to both sides. So dn over n is equal to minus lambda into dt. So now we apply integration. As we know, the lambda is a constant, so the constant is keep out from the integration. dn over n integrate is equal to minus lambda is keeping out from the integration, so the remaining term is dt. Integration of dn over n is the log n is equal to minus lambda, and integration of dt is equal to t and plus c, where c is called constant of integration. Constant of integration, say this equation is 1. To find out the value of C integration constant, we apply the boundary conditions according to boundary conditions. When the time is equal to 0, then the number of elements is equal to n naught. As I told you before, the water present in the glass originally was n naught. So at time t is equal to 0 means before disintegration t is equal to 0, the number of elements present in the nucleus was n naught. So we apply these conditions in equation number 1. Put in equation number 1. So log n is equal to minus lambda t plus c. So log n is equal to n naught minus lambda t is equal to 0 plus c. So log n naught is equal to minus lambda multiplied by 0 will be equal to 0. So we have a c, or c is equal to log n naught. Now insert the value of the c in equation number 1. So from equation number 1, log n is equal to minus lambda t plus c. Now insert the value of c. Log n is equal to minus lambda t plus c is equal to log n naught. Okay, my dear students, now I transfer log n naught towards the left hand side. Log n minus log n naught is equal to minus lambda t. Okay, as we know the log A minus B is equal to log A upon B. So this term will be equal to log n upon n naught is equal to minus lambda t. Okay. Not so complicated equation. You must know the differentiation as well as integration. It's very important for the mathematical models. Otherwise, if you don't know the derivation, differentiation, and integration, we cannot solve the mathematical models. So mathematical models for these equations, integration and differentiations knowledge is must. So we start from here. Log n upon n naught is equal to minus lambda t. To eliminate the log, we apply the exponential function to both sides. Apply exponential function to both sides. So the E log n upon n naught is equal to exponential function will be minus lambda t. As we know, the exponential function and log are inverse to each other, so they will be cancelled. The remaining terms are n divided by n naught is equal to E minus lambda t. Okay, now we can cross multiply n naught to the right hand side. So the n is equal to n naught E minus lambda t, or the n is equal to n naught E minus lambda t. Dear students, this equation n is equal to n naught E power minus lambda t. As I told you earlier, the n is the remaining terms. N naught is the original number of atoms present in the atom, and E power minus lambda t. Lambda is the decay constant and t is the time in which the disintegration happens. The disintegration, as I told you, is not a uniform process, it's a random process, and this random process is directly connected to the exponential functions. So if you draw the diagram of the random function regarding to the radioactivity, so this is the time and this is the number of the original atoms. So we will take a curved line is going towards there, and this line shows a decay. This is the number of original atoms. So when the time is going to increase, suppose here the time is half, so the half of elements will be disintegrated. My dear students, in my next lecture I will tell you about the half-life and mean life, and we will solve some numericals. Hope you understand my lecture. Thank you.